Welcome to another options video. In this options video, I would like to talk about creating option pricing models, and I'd like to think through the characteristics that would have to apply to or hold for a given option pricing model. In other words, what would the option pricing model have to ensure would be true about the price of a call or a put given certain circumstances, okay? And so we're going to go through five different characteristics that would have to hold for both calls and puts. And when we look at these, we're going to define the required characteristic. We're going to state what it looks like. We're going to show what a disequilibrium would look like with respect to that characteristic. And we're going to show how we trade to arbitrage the disequilibrium. And then we'll talk about how good markets work to restore equilibrium prices. Okay, so talk about option pricing models now. So let's start off by talking about calls. And in particular, we'll talk about the first characteristic that has to hold if we're building a call option pricing model. And that simply is that the price of the call must be less than the price of the stock at a given point in time. And notice I don't have any indication at all for the strike price of the call. This is just no matter what the strike price. The value of the call has to be less than the stock price at that point in time. Okay, let's look at a violation of it. Let's assume that at a certain point in time stock price is, let's say, $25 a share, and assume that there exists a call option. Now get this, with an exercise price of 0 and its price at date 0, let's just say is 26. Well, of course, it's just patently ridiculous because why would you ever pay more to have the right to buy something that's priced at a lower price? So, I mean, right there, logic kind of comes into play. But it might be helpful to look and at this a little more deeply and think through what's going on here. So here we have a 0 strike price. That's actually quite interesting, right? You wouldn't have to pay anything when you exercised your option. Strike price is 0. So that's the this is an example of a violation of the equilibrium condition. Why? Because we clearly see here that the price of the call at date 0 is greater than the stock price at date 0. So that's why this is a violation of the rule which says that this has to be true. Okay? Well, what will we do? What would we do? Well, let's look through. Let's think through this, okay? Well, so what we're basically saying is the call is overpriced, the stock is underpriced, so, and since this involves the call price necessarily being less than the stock price, let's do this. At date 0, if we saw this mispricing shown right here, okay, what could we do? We would buy 100 shares. And then the cash flow associated with doing that, of course, would be we would be out $2,500. And then we could write one of the calls with an exercise price of 0, in which case we'd receive $2,600. And we notice that we get a net credit with this combination of trades, and we get $100 coming in to our account. Okay, you'll recognize this. This is a covered call, long stock, short a call. Okay, that's fine. Well, let's look at, we got two positions. We're long 100 shares. We're short 1 call with an exercise price of 0. Let's look at the value of these two positions at, some point in time, maybe a minute before option expiration. Why do I say that? Well, because then there's time to close our positions before we have to deal with exercise or assignment. Here are some prices that could exist for the stock right around option expiration. Zero, we'll pretend that's possible. $1 a share, $24 a share, $25 a share, $26 a share, and we'll also look at $27 a share. Okay, so let's think about the value of our position if this is true. Let's start off with this zero price. Well, the stock is worth nothing. In equilibrium, the call value will, of course, be the intrinsic value. And we know that the intrinsic value for a call is the maximum of S minus X, or 0, times 100. Okay. And so here, stock price is 0 and strike price is 0. The call's obviously worth nothing. The maximum of 0 or 0 is 0 times 100 is 0. So that value is 0. In other words, no cash flow necessary. Like, we own 100 shares, we sell them, we kind of get 0. We receive plus 0. Of course, that's ridiculous. And we sold the call to open, so we have to buy to close, but it's worth nothing, so we pay 0. Now, again, of course, these are silly because 0, it doesn't have a sign. I recognize that these are silly, but it gets you thinking. This is potential cash inflow here, potential cash outflow there. But they sum to 0, but don't forget that our cash flow at position initiation, our net credit, was $100. So we can talk about our profit, if stock price is 0, being $100. What if stock price is 1 at option expiration? Well, our 100 shares are worth $100. Okay? Because we have $100 at $1 each. The call with an exercise price is 0 and a stock price of 1. You have the right to pay 0, so it's worth 1. So we look here, we have 1 minus 0 is 1 versus 0, which is the max. Well, 1 times 100 is 100. So we'd have to, since we sold open, we'd have to pay, to buy to close, we have to pay 100. Okay, so, but our net credit is still $100. So here we have 100 minus 100 and 100, so our profit's still 100. What if stock price is 24 at option expiration? Let me change the color here. What if stock price is 24? Well, then 100 shares are worth $2,400. And our short call, again, will be 24 minus 0. That's bigger than 0, so it's 24 times 100 or 2,500. That's what we have to pay to buy to close. We have to pay $2,400. These cancel out, but we still got this $100 here, so our profit's 100. Same thing at 25. The stock is worth 2,500. The call's worth 2,500. So we'd sell our stock and receive 2,500. We'd buy the call to close, and we'd pay 2,500. But we still get this $100. We got that when we set up the position, so our profit's 100. And you can see this is going to be 2,600 and minus 2,600. But 100 there, so 100 profit, and of course this is 2,700. The value of 100 shares, the stock price is 27. The value of the call in equilibrium is going to be 2,700. We got to pay that to buy to close since we sold to open, and so we shell out 2,700. So they cancel. There's the 100. We still make our $100. Whoops. We still make our. Oh, don't know what I did there, folks. Sorry. Hold on. This, what I'll do is I'll erase this, and I'll just put it right here, 100. There we go. And let me make that a little neater. Sorry. Trying to separate this last thing out here, and our profit is going to be 100. Okay, very good. So it's obvious now. My goodness, no matter what happens, given this position and the prices, that we make $100 no matter what. That's pretty neat. That's how we'd exploit the mispricing. It's an arbitrage, obviously. But what about good markets? Gosh, can this last? Well, no. These prices here represent a disequilibrium. Right? These prices here represent disequilibrium. But think about what we're doing. We are buying stock and writing the call. Well, we're bidding up this price and we're driving down this price. And eventually, as this goes higher and that goes lower, they're going to cross. And at some point, the number that we pay is going to exceed the number that we receive, and this is going to turn negative. And when that turns negative, then that's the first possible combination of stock price and call price that is a potential equilibrium. So good markets are such that the actions of the arbitrageurs in the trades, in taking the trades they make in order to attempt to capture the arbitrage, those trades they make will actually drive the price of the stock and the price of the call option in the proper direction so as to restore an equilibrium pair of prices. And that's very interesting. So here what we've shown is that in equilibrium, call price has to be less than stock price. This is the most extreme statement for calls. Well, let's make the most extreme statement that we can possibly make for puts. Okay, so now we're going to look at puts. Okay, and the extreme statement is this. The price of a put has to be less than the strike price of the put. The price of the put has to be less than the strike price of the put. Must be. Can't be greater than. Why is that? Well, so again, this is a statement of the equilibrium condition. Let's look at what happens. Well, the disequilibrium with the price of the put is greater than its strike price. That's the disequilibrium. And so here we've identified the disequilibrium position. And now let's put some numbers to it. Let's say we have a put with an exercise price of, just make up a number, 16. That has a price right now of date 0 of 17. Okay? So there we've identified with numbers our disequilibrium. The next step to look at is, well, how do we arbitrage this away? Well, this one's kind of easy. What we do is we are going to short the put with an exercise price of 16. Okay, that's what we do right now at date 0, and the cash flow, of course, is plus 1,600. I'm sorry. The cash flow is not plus 1,600. I apologize. The cash flow is plus 1,700. Right? Of course. Sorry. Cash flow is plus 1,700. Strike price is 16. Okay, so we do that. Well, I mean, how do we know that that's a good idea? Well, let's check. Let's look at the value of our position at, say 4 minutes before option expiration. So again, our position is we are short one put with an exercise price of 16. And let's look at the value of this position at some assumed stock prices at OE 0, 1, 2, 15, 16, 17. Yeah, that's interesting. Okay. And then we'll kind of see what goes on here. Well, for a put, keep in mind, put it here in purple. I guess. The intrinsic value for a put is the maximum of x minus s, or 0, multiplied by 100. Okay, and so x is a strike price, s is a stock price, so keep that in mind as we go through this example here. We're going to assume that the equilibrium pricing holds at option expiration, or 4 minutes before it. Okay, so in this case, we have the stock price is 0, and the right to sell at 16 will be worth, on a per share basis, $16, but multiplied by the 100 is $1,600. And since we wrote the put, that's what we have to pay to buy to close our position. So that's the cash flow here is minus $1,600. But when we opened our position, we had a credit, and that credit was $1,700. Right? So our profit would be 100. Okay. All right, fine. Well, let's look at the circumstance when stock price at OE, or a few minutes before, 4 minutes before, I guess I said, is $1. Well, the right to sell at 16 when the stock price is $1 is worth 15 on a per share basis, or 1,500 for the put, and since we sold open, we have to buy to close, and we have to spend 1,500. But our credit was still 1,700. Well, that's cash we have in our account, so there our profit is 200. What if the stock price at OE was $2? Well, put it over here, $2. Well, the right to sell at 16, stock price of 2, so we have over here 16 minus 2, so 16 minus 2, which is 14, that's bigger than 0. 14 times 100 is, 1,400 is the value of the put. We sold to open, so we have to buy to close, so I shell out 1,400. But that credit was still 1,700, so now I make $300 profit. Interesting. Let's look at the stock price of 15. So over here we have 15 minus, we have 16 minus 15, or 100, when we multiply it by 100, and so that's what we got to pay to buy to close, so minus 100, but we still got that $1,700 credit. So there we make $1,600. And of course, you can see at a price of 16, the put is worthless, right? At the money puts expire worthless in equilibrium. We still got the plus 1,700, so this is plus 1,700. And of course, if the stock price is 17, the right to sell at 16 is 0, so this would still be 0 and plus 1,700, and of course the value right there would be, again, plus 1,700. Okay, so what we've seen here is that, goodness gracious, if we ever see a put that has a price that's higher than that put's own strike price, we want to write that put, because we're going to do real well. We're going to do real well, and that's what we've proved here. Well, let's think about what happens to the price of this put. Does it stay in this at this disequilibrium level forever? No, because what this arbitrageur is doing is he's writing the put, constantly selling the put to open, selling, and when you sell that, what you're doing is you're driving down the price of that put. And so over time, the price of the put will fall, so that eventually the credit becomes, this credit here, becomes lower than the actual intrinsic value of the put at option expiration, which allows for the possibility of loss at some of these prices. And if that's the case, then that's a potential equilibrium price. Okay, so again, just so we're clear on this, good markets are such that when disequilibrium prices come into existence, wannabe arbitrageurs make trades trying to capture the riskless arbitrage profits, and their trading behavior itself is what forces prices back to an equilibrium level. That's all I have for this video. My next video, we'll look at the minimum values for calls and puts in equilibrium. Today we looked at the maximum values. So thanks for watching.